Okay, today we're going to look at writing a vector. So the formula for writing a vector is vector v equals the magnitude of vector v, which is the length, okay, times the cosine of theta, or your angle, comma, the magnitude of vector v times the sine of theta, which is your angle. So if this one says write a vector that has a length of 7 at 48 degrees, that means my magnitude is 7. Oops, magnitude is 7. And my theta is 48. Okay? So, just plug it in my formula. Vector v equals 7 cosine of 48, comma 7 sine of 48. Okay? So, it's hard to see. Okay, and then you just type that in your calculator. Please make sure your calculator is in degrees and not radians. And you will type in 7 cosine of 48. And you get 4.68. And yes, you will get some decimals. Comma, then you do 7 sine of 48. And you get 5.2. And that is how you write vector v. Okay? Okay, on this next part, we're actually going to show how this is actually used. So it says a ship travels 88 miles at 137 degrees, then travels 140 miles at 26 degrees. Find the location of the ship. So basically what we have is this ship travels 88 miles at 137 degrees. So he goes out here 137 miles. Then he travels 140 miles at 26 degrees. So something like this. He goes 140 miles. It's going to be a little shorter. And he ends up somewhere like this. Okay, that's just a rough sketch. But basically you've got two vectors. You've got this vector and then you've got this vector. Those are our two vectors. So what we need to do is we need to identify each vector and then we add them together to find the total distance, like where they're at. So 88 miles, that's our magnitude of our first vector. 137 is the theta of our first vector. Then our second vector we're going to call u. So 140 is the magnitude of u, and 26 is the theta of u. Okay? So we're first going to find v. So v equals 88 times the cosine of 137, comma, 88 times the sine of 137. Okay? So then vector v, we'll type that in our calculators. So we get 88 times the cosine of 137, which is negative 64.4. And then 88 times the sine of 137, which is 60.02. And as you notice, that is in quadrant 2 because it's a negative and then a positive. So it's in quadrant 2, so that makes sense. So now for vector u, we're going to do 140 times the cosine of 26, because that's our vector u, and 140 times the sine of 26. So we have 140 times the cosine of 26, which is 125.83, and 140 times the sine of 26, which is 61.37. If you notice now, that's in quadrant 1, which is where we ended up here. And so that's how that kind of makes sense there. Okay? So what we're going to do now is we are going to add these together to find our final destination. So I want to add the x's together. So I do negative 64.4 plus 125.83. And I get 61.43. And then I have 60.02 plus 61.37, which is 121.39. And that is where my vector ended up. So that actually means that's this vector right here. The ending up spot right there. Okay? So that's where it ends. So basically what that's looking at is this, if they would have went in a straight line, is the vector. But because they went out and then over, that's their ending point. Okay? So if it wants to know how far the ship is from the start, you're basically looking, how far is it from our center here? So basically we're just looking for the magnitude of our ending vector. So to find the magnitude of our ending vector, this is our ending vector. So we're going to find the magnitude, and magnitude is the square root of x squared plus y squared. So we've got 61.43 squared plus 121.39 squared. Okay, so we got the square root, and we're going to get a decimal answer here, of 61.43 squared plus 121.39 squared. And it's okay to get decimal answers on these because we're looking at distances, and we don't want square roots and distances. So this gives us 136.05. So that means he's 136.5 miles from where he originally started. So he went 140 and 88, so he went 88 miles and then 140 miles, so he traveled 228 miles because he went out and over. But in order to get back, if he took a straight line back, he's only 136 miles from his starting point. This is used a lot with ships when they're going out to sea and they're tracking their distances at sea. And so this is used a lot when you're driving a ship of some sort. It's also used a lot when you're driving airplanes. So if you're flying a plane, a lot of times this type of stuff is used to find your distances. So this next part says, what angle is the boat from the start? So what angle is the boat from the start? So that means we're looking for the angle of this vector. So just like we did in the 2 lessons ago, I guess, finding the angle of a vector. Okay, so to find the angle of a vector, we do the tangent inverse of y over x. Remember, we're still looking at this new vector that we have here. So we're going to do 121.39 over 61.43. And remember, we're in quadrant 1, so we don't have to add anything to it. So we just type in our calculator, second tangent of 121.39 over 61.43. And we get 63.16 degrees. So they are 63.16 degrees from where they're at. So that's important. So like if you're driving a ship and you end up where you need to go 136 miles back, but you need to know at what degree do you need to go back to get to the starting point. And so that's here. That tells you what degree you're at from the start. And so that is how writing a vector and using the things that we've done is kind of applied.